In this lesson, we're going to be looking at slope and tables. Our objective: understand what rate of change is, understand how to find rate of change from a table. Vocabulary: slope, movement or slant of a line. Rate of change, method of determining slope by using delta y over delta x, otherwise known as change in y over change in x. Alright, we have learned that slope equals rise over run. Well, we're not always given a graph such as this with rise and run. Sometimes we have a table like this black one here. I've added a little on and I'll explain why I've done that. So if we have a table, we could graph all of the points, draw the line, and then do the rise over run triangle. But that seems like a lot of extra work. So we want to find another way to find the slope. Well, slope is also known as rate of change, which we sometimes refer to as delta y over delta x, meaning change in y over change in x. Well, the rise is really the vertical change, while vertical is talking about the y. This rise is otherwise known as delta y. So we're not learning anything new because delta y is the rise. The delta x is the change in x, or the run. Okay, so what I have here is a table, and this is how we're going to find our rate of change. What we do is, we're going to add 3 columns, and in this first column, we're going to call it delta x. So from x to x, we're going to figure out how far we move. Then we're going to have delta y, and then the last one, we're going to have delta y divided by delta x. And this first column we're going to cross out because we have to do some movement. Now I'm going to show you exactly how we use this and how we then turn these rate of changes into slope. So here's example 1. I have a table. I could easily take this table, graph it, draw the line, and then figure out slope that way. But instead, I'm going to use our rate of change table. So I'm going to put in delta x, delta y over delta x, and then I'm going to put the slope up here when we're done. I cross out the first one. This is how it works. I'm going to use different colors to kind of highlight what's going on in each one. So we'll start with blue. What we do for delta x is we start at -1, that's our first x, and we go to +1. So how far is it from -1 to +1? Well, -1, we go to 0, then we go to 1, so it's 2. Okay, now we're at 1, we're going to go to 2. So how far is it from 1 to 2? Well, we start at 1, and we go to 2, so it's 1. Now we're at 2, we're going to move to 6. So how far is it from 2 to 6? 3, 4, 5, 6. So we're 4 away. And then we go from 6 to 9, which would be 3 away. Think of how we can find that a little bit quicker than just counting. Alright, let's go to delta y. To do delta y, we're going to do the same thing we did in delta x, except with our y values. 5 to 9, well, that's a distance of 4. 9 to 11, that's a distance of 2. 11 to 19 is a distance of 8. And 19 to 25 is a distance of 6. Now what this says is to take your delta y and divide by the delta x. So we're going to go 4 divided by 2, 2 divided by 1, 8 divided by 4, and 6 divided by 3. And all of these should reduce to the same number, whether it be a fraction, a decimal, or an integer. So we get 2, 2, 2, and 2, meaning our slope is positive 2. Alright, let's practice it again. So now we have this table. Again, I'm going to fill it out. First one is unneeded. Okay? I'm going to do blue in the first one. 0 to 3 is 3. 3 to 9 is 6. 9 to 15 is 6. 15 to 24 is 9. So we've got 3, 6, 6, 9 there. Okay, in red, 20 to 19 is 1. 19 to 17 is 2. 17 to 15 is 2. 15 to 12 is 3. Here's the thing though. From 20 to 19, we go down 1. So that's a negative 1. From 19 to 17, we go down 2. 17 to 15, down 2. 15 to 12, down 3. So anytime our numbers are getting smaller, those are going to be negative numbers. You can put the negatives in right away as you're doing these instead of going back through like I did. Just be wary that as the numbers go down, that would be negative numbers. Alright, now we're going to create our rate of change. Negative 1 over 3, negative 2 over 6, negative 2 over 6, negative 3 over 9. Well, if you type these into a calculator, you're going to get a decimal that goes on forever, so it's going to be best if we just reduce these fractions. So this one is negative 1/3. Negative 1/3 as you divide top and bottom by 2. This one would obviously be the same as it started out the same. And divide both of these by 3, we get negative 1/3. So this slope is a negative 1/3. Alright, if there is any part of this video that you didn't understand or you need to rewatch, make sure you pause, rewind, and rewatch it, and bring any questions to class. Thank you.